find your way back home.
Alright, so as you might have guessed, today's video is about basic plant organs, specifically of vascular plants. Vascular plants are specifically plants that have conducting tissue, so think of them as those types of plants that are able to conduct water and minerals throughout their body, through the use of roots, stems, and leaves. Non-vascular plants usually do not have these organs, and thus are significantly less cool. Just think about it. Would you rather have this, a moss, in your garden, or something like this tree right here? I mean, I don't know about you, but I'd pick the tree. Anyways, vascular plants have to be able to absorb water and minerals from below ground and CO2 and light from the surface, which is where their roots, stems, and leaves come into play, their way to acquire resources. Let's start off by talking about the root, the organ that anchors a vascular plant in the soil, absorbs minerals and water, and often stores things like carbohydrates for the plant's use. The root system starts off with a primary root, which originates in the seed embryo and is the first thing you usually see emerge from a germinating seed. I'm sure many of y'all are familiar with it. Once out, the root soon branches to form lateral roots, which can also branch, forming a lengthy root system to help anchor the plant and acquire resources from the soil. Large-massed plants usually have a taproot system, with one main vertical root called the taproot and a bunch of lateral roots coming off of it. This type of root system enables the plant to grow taller without it toppling over. Smaller plants usually have a fibrous root system, a thick mat of slender roots spreading from out below the soil surface. In these plants, the primary root usually dies early, preventing a taproot from forming. This leads to more of a mat of roots forming all over the soil, which is also why many of these plants are known to help keep the soil in place, especially during things like tornadoes or high winds. You guys can take grass for example. Now it's time to look at the more interesting types of roots. We'll call it that. Here we have the prop roots, which are supposed to be advantageous to top-heavy plants such as maize, but really just look like if a bacteriophage suddenly became a vascular plant. Here we have pneumatophores, also known as air roots. These are advantageous to those plants that live in heavy swampy environments where flooding usually occurs. The roots grow like this as a way to obtain oxygen when the ground is saturated with water and is low on O2. But this is not the only thing these roots are advantageous for. For all of my Avatar The Last Airbender fans out there, I would imagine these are perfect for airball, just hopping from root to root. Anyways, in many root systems, the absorption of water and minerals occurs primarily near the tips of elongating roots, where vast numbers of root hairs, thin finger-like extensions of the root, emerge and increase the surface area of the root. Alright, enough about roots, let's get into stems. Kind of the least exciting plant organ, stems. The chief function of stems is to elongate and orient the shoot, which is basically new plant growth away from the stem, in a way that maximizes photosynthesis by the leaves. Each stem consists of an alternating system of nodes where the leaves are attached and internodes, the stem segments between the nodes. Speaking of leaves, let's move on. I told y'all, stems are kind of uninteresting. Thankfully, there is a bit more going on with leaves. I'm going to pass the segment on to our editor and co-host, Moz, because for some reason, he really likes leaves. Something about chikorita?
Alright. So in most vascular plants, the leaf is the main photosynthetic organ. In addition to this, leaves help exchange gases with the atmosphere, dissipate heat, and defend against herbivores/pathogens, using leaf storm obviously. In addition to using leaf storm, some leaves have a dense covering of hair on them, helping the organ keep herbivorous insects off them. Anyways, a leaf consists of a flattened blade and a stalk, and the petiole, which joins the leaf to the stem at the node. Leaves can come as a simple leaf, which is a single undivided blade, or compound leaves, where the blade consists of multiple leaflets. Categories such as these, leaf shape, and leaf morphology in general greatly help taxonomists identify these different types of plants. How else do you think they tell the difference between a turtwig and a chikorita? Anyways, that's all we have today for this video. Be sure to like, comment, and subscribe, and make sure to have a biotastic day!
I can't regret